Hello everybody! Now I'm going to teach you guys how to solve polynomial functions from beginning all the way to the end when you get the roots and write the complete factorization. Alright, let's look at this first example. The first question that is being asked is, how many solutions does this function have? Well, as you can see, my highest degree is 4, so therefore I'm going to have 4. Justify your answer using the given function only. Just like I said, since my highest degree is 4, I'm going to have 4 roots. So that's why I said the highest degree tells you how many roots the polynomial has. What roots did you find on your graph? So this polynomial function, I'm going to type it in Desmos, as you can see right here. And then when I graph it, I look on my x-axis to see what roots I have. Some of them are not exact points, but as you can see, I have an exact point right here where x is -2. And I have another one right here where x is 5. So those are my 2 roots that I'm going to start off with, -2 and 5. What factors are associated with the roots that you found? Just like I said, the graph crosses the x-axis at those points, which makes them my x-intercepts, -2, 0 and 5, 0. We need blank rational roots to divide the polynomial down to a quadratic. Now remember, whenever it's quadratic, that's when you get it down to x squared. Your highest exponent is going to be 2, but our original problem starts with x to the power 4. So I would have to take it down to x cubed and then take it down again to x squared. I'll have to take it down twice, right? So that's why I will need 2 rational roots to divide the polynomial down to a quadratic. All right, show your work for synthetic division. Since you guys have already seen how to do synthetic division from videos before, I'm going to go ahead and go straight through this. I'm going to multiply and add straight down, multiply and add straight down, multiply and add straight down. And I keep saying that because I'm multiplying everything that's under the line times my root and adding straight down. Now, usually you'll have your A, B, and C, but as you can see, I have 4 numbers before my remainder. So I'm going to have to do synthetic division again with my second root that I found, which was 5. So, of course, bring down the first number. I'm going to multiply, add straight down, multiply, add straight down, multiply, and add straight down. Now I have my A, B, and C. So, of course, I'll plug into the quadratic formula. And then everything that's under that square root, I will type in my calculator. That gave me 841, which happens to be a perfect square of 29. So when I split them up into 2 fractions, my first one that says 13 plus 29 over 60 gives me a root of 7/4. And my other one, 13 minus 29 over 60, gives me a root of -2/3. So when they say list all of the roots for f of x, I have -2 and 5, which is what I use for my synthetic division. And my last 2 are 7/4 and -2/3. When they say write the complete factorization, it's pretty much opposite of the roots. As you can see, my first root is -2. The opposite of that would be +2, right? So I'll write the factorization x plus 2. My second root of 5, the opposite of that is -5, so I'll write x minus 5 in parentheses. And then, I don't know if you guys remember the chair I taught you guys in class, where you bring the denominator in front of the x and write opposite of the numerator. So it will be 4x minus 7, the whole bottoms up ordeal we did in class. And then my last root, which was -2/3, I'll do the same thing, which would be 3x plus 2, because opposite of -2 is +2. And that's it!